Hello everyone. Before we proceed on, I would like to thank Astronomer for sponsoring our today's video. So if you're diving into the world of data, Astronomer's product Astro makes it super easy to orchestrate workflows and manage complex data systems more efficiently at enterprise level. So whether you're a data engineer or someone who's more passionate about data, so you should definitely check out Astro's and its features to see like how they can help in transforming your organization's data journey more efficiently. So I would also provide the link in the descriptions so you can explore around Astronomer and its products on your own. Thank you.
Hello everyone, I welcome you all to our today's mock interview session with Sanyam. Today he has got around like 3 years of experience in data engineering. So we are going to solve two problem statements, and then we will proceed ahead with basic fundamentals around big data engineering. So hello Sanyam.
Hey, hi Manoj.
Hello. Yeah. So let's get started. So I have shared you a Google Docs link. Can you just try opening that and share your screen?
Yeah, sure. Just give me a sec. Let me know if my screen is visible.
Yes, perfect. It's visible. So let me just help you understand this question, and you can just start to like solve this problem. And if you have got any questions, you can let me know.
Sure.
I'll try helping you. So you have to find the top five movies. So imagine that you have been given a table where you have like three different tables, which is users, movies, and watch records. So assume that this is a kind of data which is related to streaming platform. So out of this table, like you have to find the top five movies with the highest average rating among the users who has signed up in the last 12 months and have watched at least three movies. So the result should include the movie title, average ratings, and the total number of unique users who has rated the movie. So you can scroll down and check on the schema for each of the tables. So you can take a minute to understand this data, and if you have got any doubts, you can let me know.
I think user. Okay, user. So first is this. So this 12 months is like from current date, or is it with the movie date, or like what?
So it's based on the user's sign up date. Yeah, so the user should have been signed up with the platform for at least 12 months.
Okay. Yeah. So like this. Actually, this basically the user should be signed up with the platform like for at least 12 months. Like this 12 months, we have like this is a relative date, right? So we have to calculate this from the current date, or
Okay, maybe let's do it as let's imagine the users who has signed up only in the last 12 months. So I'm not going ahead with the users who has signed up like beyond the 12 months. So I have to like find the ratings of the movies which has been released on the last 12 months.
and
So this is actually a bigger problem statement. So before we proceed on, just try to like help me understand your approach on how you are trying to solve this problem statement, and we shall see if there is any corrections would need.
yeah, sure. First thing is we have to know the users who have who have signed up in the last 12 months and they have watched the at least three movies, right? So first is we can filter on this user table to get only those users who have whose sign up date is basically less than yeah, no, a sign up date would be sign up date would be greater than equal to current date minus last 12 months, or like we can do a date for a year.
Mhm.
Then this will give me only those users who have signed up in the last 12 months, and then we can join it with this watch record table. Let's say this is a table. So in this, if we map the user ID, so we'll get on those movies. So we get okay, like let's say in last 12 months 10 users were signed up, so we get to know okay this 10 users have watched which movies, right? And then if we calculate the count on the movie ID. So then we can get okay, each user have watched how many movies, and then filter on the users who have watched movies like three or more movies greater than equal to three. So we get to know okay, these are the users who have watched this movies,
Right.
right? And now we have to find the top five movies with the average rating. So we get to know, okay, this is our result user set. Now, if we again map it to the watch records and we get to know, okay, these are the movies which these users have watched, and then this average rating. So this average rating I have to calculate only for this users or all the users.
The particular users which you have filtered.
Okay, right. So then we have to just first calculate the average, like after filtering the records with the result set of users, we have to calculate the average on the rating. Then we can use row number to rank the rating on, like to rank the movies on the highest rating. Like this will give me top five. Like if we want, like if there is call, if let's say there are two movies with the same highest rating, if we want those two movies as well, then we can use dance rank in this case. So basically we can rank on the rating, and after ranking we can basically filter the records where the rank would be less than equal to 5, so we'll get the top 5 movies.
Yeah. Well, I'm good with your approach. Maybe you can start writing your SQL query.
Okay, so
So, which approach are you going to take? Is it going to be a subquery or a city expression?
this will give me the user IDs which have the sign up date and sign up in the last 12 months, and I've watched at least three movies.
Yeah.
So this will become my user set, and now to find the now I have to find the so
Okay. So, with this, now you will have the list of the movies with the user who has signed up with last 12 months and also who has rated at least three movies.
right.
Right, perfect. So the next probable thing would be you would have create a city expressions and based on the ranking you would have filtered the first five, right? Yeah. Let's skip that. So I'm good with your solution. Let's move on to the next question. So it's a PySpark coding challenge. Yeah. Can you just scroll down a bit to show the complete question? Yeah, you can scroll up. Scroll up.
If it can, let me just.
Yeah, perfect. Yeah. So imagine that you are being given a PySpark data frame. So you can see the schema as like user ID, latitude, longitude, and city. Okay.
Yeah.
So for certain data, you have the city column value, but for some, you do not have the value. It's been calculated as a null. So you are being given a situation where you have to fetch this city name based on the geolocation, like based on the latitude and longitude you have to call an API, and with the API response you probably have to update your data frame with the city name. So
Okay.
here are the API details, where let's imagine that you are using this particular API, and for this API you are providing the input as latitude and longitude, and it's a get response. So in the response you get it as like city, and this city as the tag and city name as its value.
Got it.
So before proceeding ahead, you can just let me know about your approach, and if there is any problem with that, so we can just discuss about it and try finding the right solution.
Yeah. So what I was thinking is first we can filter the so like since my first we can filter the data frame on the basis of salary column where my city value will be null, right? So we'll get and we can select the latitude and longitude. So we'll get a data frame with the latitude and longitude where the city is null. Now from this, what we can do is maybe we can collect the data, like it would be a array of two columns of latitude and longitude, and then get a city for each of the latitude and longitude
Hmm.
using a call or fetch API. And okay, so we get the response in this city and city name.
So how do you make a response for each and individual records in the PySpark data frame?
Yeah, taking so now. Okay, yeah. So what we can do is yeah.
Hmm.
Uh, First I'll filter it on the basis of the city where my city is null and select the three columns: user ID, latitude, and longitude.
Hmm.
Then we'll make a call request to get this API, like to make this get API call, and with oh sorry, and basically first after filtering the data, we'll collect the data. So we'll have a array of maybe dictionaries of with values 140 and this, right? So we can fetch the latitude and longitude values from there
Hmm.
and make the call request. After making the call request, so we get a response in this way, like city and colon city name. In this response, we can add the user ID and latitude and longitude from the using which we have made the call request. And like finally, what I'm thinking is I can make a array of this whole dictionary with all these values like user ID, latitude, longitude, and city. And with this, I can create maybe a new data frame.
Okay, so if I understood you correctly, so basically you are trying to read the data frame. After you read that, you filter the columns which has null as the city, and after that
Right,
you will convert the data frame into an array, and then you will make a API request for each of the elements in the array, and then with the enriched data, you're again going to create a data frame, right? So is there a way without converting into array, can we just do it straight away from the data frame itself? So I'm just wondering why there would be a need to like convert it into an array when you can work ahead with the data frame itself. So
yeah,
have you
no,
ever heard about UDF functions, user defined functions?
yeah,
Okay. So when you said you're going to like convert it into array, like so you would have probably created a function which is going to make a API call, and through the response you're going to enrich your array, right, with a
right.
new city name. So why can't you do that using this UDF functions? Within the UDF functions, you can try creating the functions and utilize the same with the data frame itself, right?
Okay, so actually I've used like UDF. Okay, I work with this mostly.
All right. Yeah, yeah, no problem with that. So I was just expecting some different solutions for this problem. So that can be like multiple solutions for a single problem, but we have
Uh,
to like explore around like which can be the optimal way of doing it, right?
okay, okay. So basically, yeah, I got your solution. So basically, we can pass. In the UDF, we can pass both the columns as a series, and then like uh, we can iterate over both the columns simultaneously and get call the API and fetch the value, and that value like we can return. So basically, what we can do is we can create a series of this response entered into a this, and then store it in the city. And do this. Uh, so I'm just we can fetch the city name, like we can get this, and I'm just thinking about the response of the function because what I'm trying to do is I'll update the city column so I can use this column and in that city, and then there I can call a call the call my UDF, where
Right.
I'll pass the latitude and longitude
Latitude and longitude.
columns, and I'm just thinking about what my UDF will read.
So UDF is obviously going to return the response of your API call. So your response is basically a dictionary. So out of the dictionary, you have to get the value of the city.
Right.
Yeah. So yeah, I guess we are good with the coding and the query. Yeah, let's move on for the further discussion. You can unshare
Oh,
your screen. All right. So I went through your resume, so I could see that you have worked on with Delta tables. So before we proceed on, can you please help me to understand how Delta Lake is different from Data Warehouse with some use cases? Can you share some examples of star schema and snowflake schema used in Data Warehouse?
okay. So, Delta Lake is basically different from a data warehouse in a way, like we can in a like let's say in a Delta Lake, right? We like in one of our use cases where we were reading the data from APIs, right? So we it was coming in a very unstructured manner. We can directly store that data as a raw files in a Delta Lake, but in a data warehouse, we have a more structured data where we can query the data from the API that we receive. Like we can define that API data that we are receiving from the different API. And the other is like in my Delta Lake, we can like have a very normalized data. But generally in data warehouse, we use to have denormalized data that could be used for the analytical purposes. About the star schema and the snowflake schema, like I have not used those too much.
Yeah, no problem. So I have again a question with Delta Lake and Data Warehouse. So I understand the problem statement which you are trying to use with your project. Can you just help me to understand the fundamental differences between a Delta Lake and a Data Warehouse?
So basically, Delta Lake is mostly used to store the historical data with it could be a raw data and structured or structured data, whereas like generally data warehouses are for the, as I said, analytical use cases where we can query the data. It is of more of a structured table format data. Like that could be maybe used for data dashboards and like could be used for the business people to get insights from the data.
Okay. So have you ever heard about this asset transactions?
No.
Okay, no problem. So I can also see that you have worked on orchestration tools like Airflow, right?
Right.
So can you just elaborate in detail about the advantages and disadvantages of using
So yeah, advantages it could be like we can create our DAGs to like where we can like in a very Pythonic way we can create functions and all while creating a DAG like where we can define let's say we can like we can schedule our jobs and we can specify how like what are the different stages of that job and how this all tasks would be linked with each other. And we can also in the like while using Airflow we can have our variables and connections stored in maybe in the secret vault or the UI or in the Airflow Metashow DB that we can use at the time of the execution of DAG. So we don't have to hard code all the variables or connection that maybe we would be using in our some tasks to connect to maybe let's say AWS cloud or some database. Right. The disadvantage could be so like if we have a lot of DAGs, so we have to manage the Airflow worker scheduler. There are like different Airflow ports, worker scheduler, and UI. So we have to manage all of those. And like sometimes if there are a lot of DAGs, like if we have a lot of DAG scheduled at a time and we have less worker nodes available, then like Airflow can maybe what do I say? Like it won't be able to run the DAGs, so we can
so
end up in
you are saying scalability as a disadvantage, right?
not exactly the scalability, but like we have to manage that according to our need, like how
Mhm.
much we like while while working with Airflow, we have to manage that like upper depending upon our use cases and load, we have to manage that scalability. Like there are, I'm not sure about the default worker node, but like if we have more concurrent tasks running, and that are more than that default value, then it causes the scalability issue.
Okay. So in your project, are you been using your open source Airflow version or is it an enterprise version?
So we are using a open source version where we are deploying the Airflow as a Docker in a Kubernetes.
I see. So what are all the alternatives you could think of instead of managing the servers manually using the Airflow? So you might have
Uh,
also explored about around different tools which provides the enterprise edition of Airflow, right? So what
yeah,
are all those?
there is a managed Airflow by AWS itself. This is one of the tool. Then those other tools as well. Like I'm forgetting the names.
Okay, so what is the reason behind like, planning to manage the server by yourself instead of going ahead with this enterprise edition?
Actually, like we are using the open source Airflow before I joined, so not sure.
Okay, yeah, no problem. All right, let's get move on to Spark. So if you have been working on Spark, so you might have definitely worked on some optimizations and all those things, right? So can you just
Right.
give some examples on what are all the optimizations which you have implemented in your project?
Yeah, sure. So there was one project. So what like it was a first it was a Python project. So that what happens is like there was a pipeline that customer used to run, then that is was all in the Python, and the data set was used. So that pipeline used to take around 24, like 48 hours to run. So what we did is we converted all those operations, like there were pandas operations which were the row transformation. We converted those on into all into column transformation and into Spark, and that basically reduces the time from like 48 hours to just 20 minutes. 12 to 20 minutes. This is one. Then secondly, so there was one business pipeline where we were having many tables. So we were reading the data from many tables and then doing all the joining and all the logic. So there were a couple of tables which were used in multiple intermediate queries. Like it's been we have written some Spark SQL. We were maintaining some intermediate data frames, and in those we were using those tables. So what we find out, right, what Spark was doing, it was reading the whole table data again and again. So in order to optimize that job, what we did, we persist the data before doing any before creating any intermediate data frame. So what it does is it was reading all, like wherever the duplicacy of those tables, it was reading then the data of that table only one time instead of the multiple times. So that this not only reduces the cost of the overall Spark job, but also the time that it used to take to run that particular Spark job.
So you mentioned that there is a particular project which was taking a longer time because it was reading the complete data frame again and again, right? So how did
Right.
you figure it out?
Yeah, so basically we used to go to the Spark UI, and there we were basically viewing the jobs and the stages, and there we find out like in one of the stages it was reading the data again and again. Like there was the in the graph DAG graph, it was showing that it was reading that table, and then again there was a task map to reading that table again. So where the this is where we found out that this job, or basically this stage, is reading the table data again and again, and then we looked again in the code and we found out, okay, so this is the issue, and that's why we persisted the
I see. Okay. To store your data frame in an intermediate memory, so you probably have got like two different options. One is cache and other is persist. So why did you go for persist?
So basically, persist not only shows data in the memory but also on the disk. So since in that particular job we have to read all the historical data, so we wanted to store it at disk so that in case of any executor loss, or we don't get like our Spark job should run fault tolerant. So that's why we for a measure of security we go ahead with persist so that the data get stored on the disk.
Okay. All right. So, have you ever faced challenges as like Spark jobs failing on your production, and how did you figure out, and what was the problem statement is been like, and how did you solve it?
Okay. So yeah. So Spark job failing on the production. Yeah. So that we have faced a couple of times. One was due to the out of like the Java space out of memory error, right? So in order to like what we were doing in that is so we have a table with a huge JSON column. So we have a JSON column in the form of a string, and we were reading that data and extracting the data from that JSON and converted it into the struct and was storing the table into the basically then we were storing that table data into another table with like we can call it as a refined table because the use case of was that for creating that refined table we were creating some more refined table for an analytical use case which need those columns, and since that particular use case need the historical data as well, so if we extract that whole of the data at once and then extract the JSON data, it would be a more complicated and a more we can say a more costly operation. So that's why we thought of let's store in an intermediate table with all the required columns extracted from that JSON, and then we'll create a final table. This will help us in the future as well. Like in case of any failure, we have to just look at an intermediate table. And so in that, I was facing a Java space memory error. So first, what we did is there is a enable vectorized reader. We turned that, we disabled that. Secondly, even after that, there was many times that table was getting like while reading the data from that table and creating that intermediate table, we were facing a scalability issue. Like after even after like scaling to too many worker nodes, the job was getting stuck at only at a one stage where it was just reading and basically creating that column, like extracting the data from that JSON column, then created into a struct column, and then just writing it. So in that stage, it was getting stuck, and we have like do fan out error like writing as a parquet or like where like to find out at which stage it is getting stuck, right? So it was mainly that where we were extracting the data and basically creating the struct. At that stage it was taking that time. So what we did, we divided all the table data into three four parts. Like we had like in the original table where that JSON column was, it was partitioned on a year month day. So on the basis of year and amount of data we had divided the table into like four parts, and we had run the job incrementally to process the data for like those particular set of years.
So, which version of Spark are you been using in your project? So, you might have definitely read out through the release documentation of Spark 3. So, what are all the major advantages you have in Spark 3 in comparison with Spark 2?
Uh, Currently, I don't remember.
Okay, yeah, no problem with that. Okay, so yeah, have you worked on any of the services within AWS?
Yes, so I've worked on the EMR S3 Athena. Then obviously, since we are storing the data in the tables of Blue Catalog, I've used. Then MSK also I've used, and yeah,
Okay,
these are the mainly services that I've used.
okay. So, since you have mentioned MSK, I probably think you might have worked on with streaming data as well, right?
Right.
So, when you're working ahead with streaming data, imagine a scenario that there are chances where for a particular record, you might even get an update value, and also the data can get deleted, and all sort of things can happen from your source. Okay, so what kind of data format would you choose to store this information? So you're
Okay,
basically
so
handling a streaming data, and your data is getting updated and also having delete operations. So what would be your data format for preference?
So basically, finally, we were storing the data as a form in the form of Hudi tables. At the end, like we were consuming the data from the MSK or Kafka cluster, and then processing the data, and then storing that as a form of Hudi tables. So in order to take care of all like insert, update, and delete operations.
Okay, okay. So basically, your Hudi helps you to like handle the update operations, right?
Right. Right.
So can you just give me some examples of the advantages which you have with this Hudi tables?
Yes. So basically, we were storing the data in the S3, right? So S3 is a file, basically a object storage where we can store any file. So basically, to manage those files in the form of tables, Hudi helps us. Secondly, if we have to do any insert, update, or delete operations, and then Hudi help us to do that because it manage all that data as a table and create its own metadata. And there is a schema evolution as well. Like if some like let's say for my current data was integer, but after some time that converted to string, so we can also do that. Use we are using Hudi. So yeah, this were some of the advantages that we are getting from using the Hudi.
Okay, so Hudi, is it a, schema on read or schema on write?
Sorry, this I don't remember.
Okay, thanks a lot, Sam. So I'm satisfied with your interview, and let's wind up. And all the best for your futures and your.
Yeah, thanks. Can you please share the feedback?
Sure. So with regards to your SQL query and your coding, so I'm like 100% satisfied with that. So when I asked you about the approach, right? So you are like very clear with your approach. So at that time itself, I was so satisfied with your answer, and I just asked you to write the SQL query just to have an understanding that how you write your query, either using a subquery or with your CT expressions. But in interviews, like most of the interviewers would expect you to write it in CT expressions because it's kind of like a little bit easier to read when you when you're writing like huge queries, right? CT expressions can make
Right.
it more appealing and can be easily understandable. And when we are writing about this PySpark code, like since I think you might have not worked on with this UDF functions and all those things, right? So that's why like I asked you about this UDF functions. When you're working with data frame, right? So if you want to like perform the individual records, you probably can use the UDF functions instead of converting the data frame into array and putting into a functions and converting
Actually,
into data frame.
yeah, like in some of the pipelines, I used that UDF function, but it didn't click at that time.
Okay. Yeah, no problem. And with regards to the theory parts, I would say I'm not like completely satisfied. It's kind of like 50-50%, because the very first point when I asked you about the difference between the Delta Lake and the
Mm,
data warehouse, the actual difference I was expecting for is that both of them provides the asset transactions. So actually the major difference between a delta lake and a data lake is actually the asset transactions, the capability of asset transactions. It allows you to update, delete, insert, and it also keeps the atomicity, consistency, and all those things, right? So every interviewer would definitely expect this keyword from you. Like when I asked you about asset transaction, you are like clueless at that point. So at that point of time, every interviewer would have thought that he has not worked on delta lake. For sure they would have thought about it. So when so basically this is a very frequently asked question. So if some of the interviewer ask you about like have you ever worked on Spark 3, definitely they are going to ask you questions around AQE, adaptive query
okay.
execution. So there
Right.
are a certain set of like optimizations which comes as part of the Spark 3, right? Before Spark 3 we
Right.
have to be doing all these optimizations manually, but with the Spark 3 it's being like adaptive, like based on your data and the volume it adapts to that and perform this
Yes.
optimizations, right? And with regards to airflow, so when I asked you about the advantages and disadvantages, I would say your answer was not much clear, so try to focus on that as well. So whenever if you are working on any sort of tools, right, so always try to
Right.
find advantages, disadvantages, and what are all the alternatives. So when you are going ahead with this managerial kind of interviews for product based companies, right, so that's what they expect.
Right.
Yeah. And so you should majorly focus on your theoretical parts with the coding and SQL. I'm good with that. Yeah.
Okay,
And
thanks.
also like another
Huh.
final feedback. So when you are speaking about your project, right, so I asked you a questions about like have you faced problems with your Spark job failing on productions. So you gave
Right.
me an
Huh.
answer, it was too long, but most of the answers was repetitive. So like it just give me a sense like you're just trying to like match up things as like what you don't know. It just appears to me like that. So when you're just portraying your answers, be more crisp. So what's the exact problem statement, how did you find it, and what did you do to solve this? So it has to be just the three statement. You have to be more crisp
Okay.
on it. Yes. And that's all from